Here is such a nice looking geometric problem. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So welcome to another video on prime logic. What is the ratio of the area of the quarter circle over the area of the semicircle? So by the way, this image is not drawn to scale, so it's not accurate to scale. So for the sake of simplicity, let's assume that the radius of the quarter circle is just 1 unit. So this is going to be the point of tangency, right? Because we know that this semicircle is tangent inside or inscribed inside this quarter circle. And this is going to be, let's say, the center of this semicircle. So if we kind of join this point together, so from this part to this part, from also this point to this point to this points of tangency. So we know that the radius that is drawn to the point of tangency, it is perpendicular, right, to the tangent itself. So we know that this is 90 degrees, this is 90 degrees, so is this, and so is this. So this shape inside is a square. And this is the radius, let's name it as R, of this inner circle. So let's write down the Pythagorean theorem here for the diagonal of this square. So the diagonal of this square can be calculated using the Pythagorean theorem. So let's name this diagonal as D. Say so D equals, so we know that it is the diagonal of any square is square root of 2 times the radius. So D equals square root of 2 times R, or R square root of 2. In other words, like R squared, so that's the Pythagorean, right, plus R squared equals D squared, then it is 2R squared equals D squared, then D equals R square root of 2. So for those of you who wanted to know so where this term came from, this is the explanation for that using the Pythagorean theorem. So we know this value, this diagonal is R square root of 2. And then let's make another right angle triangle here. So let's connect from the center of the quarter circle to this point here. So this is another right angle triangle, right? So this is R square root of 2, and this is the radius of the quarter circle, which is just 1. So let's write it down for this triangle, this Pythagorean theorem. So we know that the hypotenuse is just 1, right? That's the radius of the quarter circle. So 1 squared equals R squared plus R square root of 2 squared. So this is R1 equals R squared plus 2R squared. In other words, so that's 3R squared. So 3R squared equals 1, and then R squared equals 1/3, or 1 over 3, in other words. So we don't need to calculate it further because we will need R squared for calculating the area. So let's put a box around this part. What is the area of any circle? So the area of a circle is pi R squared, right? So let's calculate the area of the quarter circle. So let me draw the shape here. The area of the quarter circle is pi R squared, so R is 1. And then, because that's a quarter circle, we need to multiply that by 1 over 4. So that's pi over 4. That's the first thing. And what about the area of the semicircle? It is pi R squared. So R squared is this term. So pi times 1/3, and then times, because that's a semicircle, 1/2 or 1/2, which is pi over 6. So what is the area of the quarter circle over the area of the semicircle? Area of quarter circle over the area of semicircle. So that's quarter circle is just pi over 4, and the whole thing over pi over 6, which is, we can cancel the pi's out and simplify the fraction, so that's 6 over 4, or in other words, 3 over 2. So let's put a box around it. And that's the final answer. So make sure to drop your thoughts and answers down in the comment sections below. And I want to know how you approach this problem, because the way you approach this problem is also very interesting, and I learn from you as well. So please share your thoughts and your approach in the comments below, and I have a bonus challenge for you. So what if the radius of the quarter circle is 18 units? So what is the radius of this semicircle inscribed inside? So that's going to wrap it up for today, guys. I hope you enjoyed this video, and make sure to subscribe and share if you haven't already. And see you on our next video on prime logic.